Welcome to part 2 of how to build an Arduino based VFO using the SMA clock generator. So in the previous video we looked at the circuit, how to build it, where to get the parts from, and we did a bit of theory of operation. In this video we're going to take a look at the breadboard, do some basic tests for troubleshooting just to make sure that everything's okay. We're going to download the Arduino IDE and we're going to configure the Arduino Nano that we've got here, and we're going to put some code in there, and we're also going to go through and cover some of how the code works and what you can do to manipulate it. Okay, so this is the breadboard layout. It's pretty straightforward stuff. For those of you not familiar with breadboards, we've basically got strips here, and you can see this one's actually marked blue, the other one's line there is marked red, and they're basically strips in there. They all connect up, and they connect horizontally, and it's the same at the top here. We've got exactly the same there. We've got negative and positive, and these holes are basically strips, and they connect up horizontally. Now on some boards, as you can see, as on my board, these strips are separated, so you need to put some jumpers over, providing you're using that that part of the power strip, which I am. So yeah, and there's some there as well. So yeah, pretty straightforward stuff. Now if we get to the center of the board, the strips go the other way, so they run vertically. So these are all connected together, and it's the same here for the next ones along. They're connected together, and so on. And so thus we can connect up our cables. Now obviously these coloured lines with the dots on the end, I've just made it in Photoshop. These all, they're just wires, and we're connecting everything up to make the circuit. Now along the center, this center line that runs through, there's a separator between these vertical lines, and hence that's why we can put an IC in here. We're getting our power, as we said before. It's coming from the Arduino. It's off the 5 volts, and the ground comes from the Arduino at this point and connects onto the negative rail. That comes along, loops round from this point, it goes up, and then feeds this rail. So we've just got a continuous power rail. Okay, so once we've got it all together, there's a few things we can do. The first thing obviously is to double check all your wiring, because it's very easy to make mistakes. So I always start with the power rails. Now this doesn't have any indication on this board, but obviously the outside rail here and here is negative, and it's the same here, it's negative. You can see we've got the jumpers over as we did on the layout drawing. Make sure that obviously your VCCs are going to the positive and your grounds are going to the negative on the ground rail. And of course, as we said before, we're actually getting power from the Arduino. So you make sure all that's correct. Oh, there's another thing as well for plugging in the encoder. You can see, but what I've done, I've just got a pin header, and I've just soldered the wires on there carefully. So this is a little different to how it's set up on the layout that I did, but yeah, it's the same thing. So the first thing to do, once you're happy with everything, is plug in a USB cable. Now I've got this plugged into my PC. And you see we get a light. We don't get anything because there's no program in there. But with the multimeter, I've just got this set to DC volts. And we can just check that we've got a, so 4.955 volts. Yep, so that's 5 volts. I'm going to look over the top here, which is the other orientation. Yeah, and if we look over this side, so we'll just make sure we've got a, yeah, so we've got a 5 volts all the way through. One thing I will say is, obviously, if you are, when you install this IC, just be careful with it. If you've got a wrist strap or something, I would just consider using it, because CMOS are very sensitive to electrostatic discharge. But that being said, I've really mishandled loads of them and they all seem to work, but it's definitely not the way to do things. But yeah, and you can see I've got the capacitors in. Just then, the capacitors have got a negative marking on the side, so you're going to make sure that goes to the ground. That's just another thing. But I think we're about there. Oh yeah, just one other thing. Obviously, link out wire. I've just used solid core wire. Don't use multi-strand wire. And then you just, I've got a little stripper, and you can just strip the wire down like so. Just make sure you've got a wire that's got a nice tight snug fit into the breadboard, and that way if it's loose, it'll be making poor connections. So you want something that's snug, and you know, it means that it makes it a little bit more reliable. I know it's only a breadboard, but there's nothing more frustrating trying to figure out what's wrong with you know, what's wrong with the board when it's just something like a loose connection. Okay, so there's a couple of things we can test. So, oh, by the way, yeah, this wire here, that's a screen. I've just put it, again, used a bit of you know, pin header, soldered it on, and it just fits onto the negative rail. So I've just grounded it. It doesn't go to anything, it's just a screen for the cable. But what we can test, if we want to make sure Rotary Encoder and D-type flip-flop are working, basically what we do, we go from here and we go on to D2. Let me just double check. Which one's D2? Okay, so we go on to D2. As we turn the encoder, if you watch the meter, you'll see it jumping up and down. If you've got an oscilloscope, it'd be even better. But you can see every time we move it, it keeps jumping up and down, which is a good sign. And then if we go on to the next pin, which is D3, now that should be high in one direction. So if we turn it clockwise, it's high, and if we turn it anti-clockwise, you see it goes low. Change direction, goes up. Turn it the other way, it goes low. And that's really, you know, that's as much as we can really do. Okay, so the next thing we need to do is program the Arduino. And in order to do that, we need the Arduino IDE. So if you just go to Google and just type in Arduino IDE download, it's already there because I've already done it. It'll bring you up to here. Now this one, Arduino CC software. So we just click onto this. It brings us to this page. It says downloads. Now I'm using Windows 10. I think there's options down here for using different operating systems. So I'm using Windows 10, so I'm just going to hit this one here. Now it asks us if you'd like to donate to the Arduino, because of course it's all open source, or you can just hit download, and you can get their newsletter and subscribe to Arduino. Interesting stuff. But in this case, I'm just going to hit just download, and you see that it's downloading. And I've already done this before, hence you can see 2 of them. So just let that download. Just click on it. Now I'm using Firefox, but it might be different on the browser you're using. So it's normal, usual stuff. I agree. It's up to you whether, if you've got different people using your PC, whether you want it just for you on your profile, or it's for anybody who uses a computer. Next. Allow this app to make changes to your device, yes. And then you hit I agree again. And it's going to tell you where it's going to put it, and then you hit install. Now I'm not going to install it simply because I've already got it on there. But basically what happens is once it's installed, so I'll just cancel that. And if I go here under A, we've got Arduino. Now I've got an old version, and you can see it's round, and the new version's got more of a square icon. So if we just click on that. Okay, so you open the IDE for the first time, and you'll be greeted with the window that looks something like this. And if you're not familiar with Arduino, because not everybody is, or how it works, I'll go through it, do a sort of high level run through it. We've got some buttons. So we've got a button up here which is basically says verify. That means it'll come if you write a sketch in the body of here in the body of the IDE, you can verify it, and automatically this brings up as default. This is a blank sketch. There's nothing in there. It's just got two functions in there, which is void setup and void loop. But there's nothing within there. So if we hit the verify, we can see it comes back and it gives us this information at the bottom. There's no errors. So if I went into the void loop, let's just say I just type something, and obviously this is all in C++, so you need the right syntax. But if I press verify now, look what happens. Yeah. Okay, so it's saying compilation error, blah, 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 not declared in this scope. Okay, so we've got to be very careful what we put in here, and we've got to be the correct syntax. So, of course, as I mentioned before, the Arduino IDE uses C++ as a programming language, and it basically breaks down into three sections. So if I just... So at the top here, this is where we define variables, or we use libraries. We can actually include the libraries, but it's where we define the main bits that we want to use within the program. And then we've got a section called void setup. Now this is a function. It only runs once. It says it here, run once. And this is where we configure things. So it may be that you've got libraries and they need to be started, or you've got functions and you could call the function and get it to do something. And then we've got, come further down, we've got the void loop, and this is exactly what it says, loop. It just runs over and over and over. So whatever code you've got in here, it will just continuously keep running it. So they run from top to bottom, left to right. I think that's right. Okay, so let's just verify that again. We've taken that out and see what we get. Yeah, no, that's fine. We've got no errors now. So first thing we need to do is connect up our Arduino Nano and configure it. So the first thing I'm going to do, if we go up here to Tools, and we go to it says board. At the moment it's got 18 mega 8. Well, that's not what we're using, so let's go across and we go to Arduino AVR boards, and then we come down and we should be able to find the Arduino Nano. Yes, it's here. Okay, now you can see that is not in bold in this top corner, but it's saying that that's the board we've got selected. So the next thing we want to do is come down to COM ports, and you see I click on it, it doesn't want to do anything. So what I'm going to do is plug the Arduino in. So I've got a USB cable which is running between my PC, which is what you see now with the IDE, and I'm going to plug in the Arduino Nano. Okay, we got the little sound, and it's actually gone into bold up here. which I think that's basically telling us that it can see the board. And if we come to tools again, we can come down, and indeed, yes, it's found it on COM port 13. So yep, that's all good. So there's a bit more configuring to do. Now, this is already set because I've actually already set it, but if we come down to this section under tools, it says here Atmega 328. Now that's the microcontroller, the Atmega 328P, and it's saying old bootloader. Now you've got to get this right, because if you've got the wrong bootloader on it simply won't communicate with the Arduino. So that's selected, which is good. So we can hit a verify. We know it's good anyway, we've done it. And if we hit this button, this is the upload. Now there's nothing in here, this is a blank sketch, but it will still upload. And as you do it, I'll show you the thing. You should see a little bit of action on the LEDs on the Nano. So there are XTX LEDs. Done uploading. So we've established that we've got our Arduino IDE installed, and we are seeing being able to communicate with our Nano board. And if you look up here in this top left hand corner, you can see it says Arduino Nano, and it's in bold, and it's got this little icon next to it. So if it's in bold, when we click on it and it looks like that, it means it can see the board. It's just doing it automatically. Now if it isn't, if you're not getting that, obviously make sure you're plugged in. You've got to be connected up with the USB lead between your PC or laptop and the Nano board. But if we go here to tools, you can just check this COM port, make sure you've got the right COM port selected. So at this point, what we want to do is we can check to make sure that the Arduino can see our I2C devices, because of course we've got an SMA 5351 board, and we've also got the OLED display, which is also an I2C communication device. Now I2C, obviously they all run on the same serial bus, so in order for the Arduino to distinguish which device it wants to speak to, they need an individual address. So what we want to do firstly is make sure that it's communicating. So the easiest way to do that, if we come over here, we hit this button here, this is the library manager, and in the box here we do a search for ITC Scanner, if I can spell it. And it gives us a list of different libraries that you can use. Now I'm going to use the first one that's up here, which is by Luis Lamas, and we'll just install that. You see down in this dialog box here, it's saying that it's been doing some stuff, installing, installed. Okay, so the next thing, we can close that. So you can open and close it just by clicking on it. And we want to go File, and then come down to Examples. And if we come down, you can see I've got a lot of libraries in here. And basically what these examples are example sketches of the libraries. We'll talk a bit more about it later, but we need to come down to this point, ITC Scanner, and we come down and we check this box here, which is Scanner. Okay, so that will open this sketch up for us, and let's just maximize that. Now, if we look in here, this is, this is their code. If you hit the verify button, as we noticed before, we just compile the code, and as you see, it hasn't got any errors. Now, it won't upload to the Arduino if it has got errors, but yeah, it's a good thing to do. We know it's working. Now, a thing to pay attention to in here, we've got serial.begin. Now, what this does is open up a serial port between the computer and the Arduino. And within these brackets here, it's got a figure 9600. Now, that's the baud rate. Now, it's good thing, just make a note of it, and I'll explain why in a second. So what we can do, we can actually upload this sketch to our Arduino. So if we hit the upload button, it's saying it's uploading complete, or done uploading. Okay, so the next thing to do is come over to the top right hand corner and hit this little icon here which says serial monitor, and if we click on it, we got a bit of garbled information there, but it's going. Now the reason I said to make a note of the baud rate, because over this side on the serial monitor, because this is the serial monitor of the IDE, so the information you're seeing is coming back from the Arduino. So what we've asked this program to do is go in and scan the I2C and see what devices it can find. And what it's coming up on the screen here, it's saying it's found devices at a certain address. So if we come over to this side, we've got baud rate. If you've got garbled information coming up, you've probably got baud rate set not correctly. See, I've set it to 57,600, and you can see it just comes up with garbled information. So you've got to make sure that is correct. So as you can see now, it's coming back up. So if we look at this, if we take a look at the information it's given us, it's finding 2 devices, which is correct. We've got 2 devices on there. Now, one of the devices, this OX60, this is in hexadecimal, by the way, that is our I2C address for the SI5351. Now, that's static. It doesn't change. So whatever board you get in there, it's always going to be OX60. Now, the other one we're getting is OX3C. Now, that has to be our display. Now, some of these displays can come with different addresses. So this is why we're doing this. Well, 2 reasons, really. A, so we know we can see the devices. If you can't see these devices, you need to go back and check your I2C wiring and make sure the module's getting power. But it's pretty straightforward. If your I2C is connected correctly, you've got SDA to SDA and SCL to SCL, you should be seeing this. So what we need to do is make a note of this I2C address. I'll just go Control C. I've just highlighted it. And what we'll do is just run Notepad, and I'll just paste that into there, so we've got a note of it. Now there's another thing we need to do, and I'll explain why later, but I'll show you what you need to do. If we just come up, and we go and see our good friend Jimmy Google and ask him what we put the hexadecimal in there, and we say hexadecimal times 2 equals, and it comes back with OX78. Now this is important, you're going to need this, so hit copy, and what we'll do, we'll put that into our Notepad, and we'll just put a note next to it. So we just made a note that that's what it is. It's this times 2 in hex. If you can work it out in your head, that is. I certainly can't. I don't have the grey matter anymore. Okay, so once we've got this information, we can now close this program. We don't need it anymore. We don't need to save it. Just hit close, and then we can move on to the next step. Okay, so the next step is to download the sketch of the VFO, the one that I've put together. So what you need to do is go into the description, and there will be a section there. It says download sketch. Click on the link and then download it. Now you need to go into the folder that it's downloaded to, and what you'll find, I've just emulated that here, you'll find this folder, well, this zip file, which is SI5351 _ VFO _ 001. So what you do, you click on that, or double click, and then we right click on it and copy it. Okay, so what we want to do is put this in the folder where Arduino keeps all its sketches. So we just hit open, and the reason I'm doing it this way is because everybody's desktops everything's different. So we get to this, you know, here it says this PC, so that'll have a different, you'll have a different path to what I will have. So this is the easiest way of doing it. So what you then want to do is go right click and hit paste. Now I'm going to not hit paste simply because I've already got that file in here, and to open the file you simply click on the INO file, and there we are. Okay, so now we've got the sketch, we need to include some libraries, and if we look here, these it says include, and it's got it says wire u8g2 lib.h, si5351.h, and easybutton.h. Now these are libraries I've used, so you need to download these, and I'll show you how to do it. Now wire comes as standard, so we don't have to worry about that. So what you need to do is go to your library manager, obviously it's this button here, and what we do, we type in u8g2, and that, I'll do a search. Now you can see I've got this one, I have got this one already installed, so I've got an option here to remove it or install it, so I'm going to leave it in there, but you need to hit install to get it to go in. Now this is the one by Oliver, this is the one I'm using, and the other libraries, you want to look for the SI5351, and again if we come down you see the list. Now Adafruit well, there's quite a number of different libraries here. The one I'm using, and this is the one you need to run this sketch, is from Jason Mildren, and it's the EtherKit SI5351, and again you just have to hit install. As you can see, I've already got it installed. And the next library is EZ, or EZ as they say on the other side of the pond, Easy Button. And again, you just need to install that. So once you've got those installed, we can then close this, and if you hit the verify, it'll compile the sketch, and as you can see there's no errors. So if we can make that a bit bigger, oops. Okay, so the other thing you need to do is, we made a note of that hexadecimal address, which is 0878, so we copy that. Now it's all going to vary on what board you use, so if we go down, and what we need to do is get into the setup, and then you'll see a line here that says U8G2 set I2C address. Now this, I'm using the U8G2 library. This is the display driver and their fonts. So as you can see, I've already got it in here, but you need to put it between these brackets. Now it's very important that we don't mess this up, because you know these brackets have to be here and that semicolon has to be there, because if it's not, it won't compile. So hit Control V, which is paste 0878. Okay, so the next thing to do, I'll hit compile, and it should load into the Arduino, and it should be running. There's a few bits on here which we'll go through in a second, but yeah, let's just compile it and get it uploaded. So let's hit upload. Okay, so that's uploaded, and I've got this preset to one of our local AM radio stations. The SDR is set to 60 megahertz because that's what I've set the IF to in the code. So what I'm going to do, I'm going to go through a little bit on the code, how to set the IF and the bands. But this video has got quite long. I didn't realise how much was going to be in this. So there'll be a follow-up video and we'll get more into the code and more things you can do. But that's basically it. So we should be able to just tune that. Yeah. We can just tune to various stations. I'm actually quite impressed with how well this thing performs. I do like this rotary encoder as well, so, you know. Okay, so let's just have a quick look at the code. Okay, so if we are at the top here of the sketch, so if we just scroll down a little, you see these, I put these bars in here. Now, within here, this is the user definable area, so you can actually go in here and change stuff. So of course at the top here we've got our IF frequency, and as you saw on the SDR, we had it set to 60 megahertz. So we just literally put in 60 megahertz here. You just literally put the number in. Now it's got to be in hertz, so you know, and it all has to be there, so it can be 60. 1, 2, 3, 4, 5, 6. So we've got, you know, 6 noughts, 6. So that's 60 megahertz. We've also got a second LO which we can set. That isn't working at the moment, but it will in the next revision. We can go through that in the next video. And what have we got? So yeah, we've got these bands here. Now these are arrays. So what we're doing is, this is an integer. We'll talk about this again later in the next videos, but that's an integer, and it just means it can take quite long numbers. And within this array we've got these frequencies, again all in hertz. So if we go along, you can see I've actually just put in there the amateur radio HF bands. Now there's a thing, if you're actually tuning around, and once you set the frequency on one of these and then go to another band and then come back, it will stay where you left it. Obviously if you switch it off, it's because it's in the RAM, so it's in volatile memory. But yeah, if you set it up and tune about wherever you left that band, when you come back to it, it'll still be there. But these are the frequencies, and I've got 15 bands. You can put more bands on, so this is maximum number of bands. That is another variable, and it sits in the body of this array. Now that has to be in there for 2 reasons. One, we have to tell the program how many parts of this array there's going to be. So it's just simply so that the compiler and the IDE, when it goes along, it knows how much memory to allocate to this this array. So yeah, we've got 15 bands. So if you added another band on here, you've just got to follow the same syntax. Literally just put a comma, and if you put 144, which is 2 meters, you'd have to change this to 16, not 166, and we can do exactly the same here. Now this is a string. Now this is just displaying what we've got between these inverted commas, so we'd need to add another one here. So you'd have to add a comma, 2 inverted commas, and we could just put 2M. So you can add bands, and you can change these and name them to whatever you want. So, you know, it doesn't have to be amateur radio bands. It'll go with anything. So also as well, with the IF frequency, if you want the unit just to produce the frequency that you've got set on these bands. So if you want it to produce, let's say here 1476000 hertz, you just change this to 0. So instead of being 60 megs, just make it 0, and then whatever is on the display will, that's the frequency that will come out of the clock generator. Now we've got another thing here, up and down conversion. This is really interesting. So if you're going to feed this into a down conversion receiver or transceiver, you would need to make it just a 1, and if you want to make it into an up conversion transceiver, you make it -1. Now there's some caveats to this, because obviously you've got to remember the range of the clock generator. It'll only generate up to around, I think it's 200 megahertz. You can get it a bit higher than that as well. I need to spend some time with it, but that's basically it. And there's another, I'll put another neat little thing in here, because if you connect, you build this and you turn your rotary encoder, and it counts down when you're turning clockwise and goes up when you're trying to turn it down. You can invert this, so you just change this from from false, invert encoder direction, and you just make that into true, and that will change direction. You can do it with the wires, the A and B wires that come from the encoder, you just swap them around. See that, or you can do it in the software here. It's very straightforward. And we've got another thing here, which is the calibration figure. Now, if you build this and you put this code in there, you're going to be off frequency, and you can't offset it. You can't fix it by just adjusting the frequencies you want to generate. It doesn't work like that. You've got to get the calibration figure and set the SI5351. There's the routine for doing it. I'm going to make a separate video. It won't be a long video, but there'll be a separate video following this video on how to do that. You will need a frequency counter, and it needs to be in reasonable calibration. The one I'm using goes down to 1/100th of a hertz. So, but if you get down to 1/10 of a hertz, you're pretty much there. You're getting into the ballpark. But again, we can talk about that in the next video. But that's basically it. Yeah, you can play around with this, and if you go to compile it, I'm just going to hit the compile here. We'll see if we've got any errors. Just if you make changes, just keep hitting compile, because if you've got a syntax error, it will tell you, and as I said before, you can't upload if it's got a problem, with the syntax, it won't upload. You can upload code that doesn't work, it won't find that as long as the syntax is correct. But yeah, okay, so look, if you've watched the video this long, I'd just like to say thanks for watching. I hope this is of interest and help to people, because I know I've been asked by quite a number of people, can we do this? And so here it is. In future videos, we could possibly make a channelized system. It's quite straightforward. But there's other things we can build on with this that can make it more interesting. And if you've got any ideas, leave it in the comments. Or if I've made any mistakes and you're having problems, leave it in the comments. And if you resolve the issue, leave that in the comments as well, because it'll help other people. So yeah, okay, well, thanks for watching. I mean, feel free to buy me a coffee. This video has taken me quite a bit of time to make, but hopefully it's it's of help to people. So until next time, see you in the next video.